So the second proof is also a fairly short proof. Okay, we're given that this diagram exists. Okay, and we can see that we've got triangle RST on the left and a triangle which we're calling VWT on the right. We've got to prove these two triangles to be congruent. And we're given two facts. One is that the measure of angle R equals the measure of angle V. So we can sort of denote that in that way. And the second given that we're writing down into the proof, body of the proof, is that T is the midpoint of RV. So T is the midpoint of RV. So I hope you see that most likely one of the things we're going to use is the definition of midpoint. Because what that will get for us is if T is the midpoint of RV, that means that T divides RV into two smaller congruent line segments. So we will have that RT is congruent to TV, or we could also say the measure of RT is equal to TV. Okay, and we've denoted that already with the two hatch marks in those lines. So we've got a congruent angle, we've got a congruent side, and so what other things would help us here? Let's see, we have one angle, we have one side. If we could prove angles 1 and 2 congruent, we would have angle side angle. Okay, so that would be nice. Or if we could prove angle S congruent to angle W, which those would be the corresponding angles there, we would have angle side, and that also would work. But I hope you see it's pretty obvious, because we've done a lot of this work so far, that we know angle 1, or the measure of angle 1, equals the measure of angle 2, because these are vertical angles. And vertical angles have equal measure. And that would be our reason for being able to make this statement. That means now angle 1, angle 2 are congruent. We can denote that in this manner. And it should be clear that we now have angle side angle on the left triangle as well as angle side angle on the right triangle. And that means that triangle RST is congruent to triangle triangle VWT. So R should correspond to V. Let's take a look. R and V correspond. They both have that one line. S and W must correspond. They're both the ones without the line. And the T's, each triangle has their angle T, and they are the ones that correspond as congruent because they are vertical angles. So by angle side angle, we can say that triangle RST is congruent to triangle VWT. We can move on to the last problem here, and let's look at this proof. We're given two triangles, one on the left, one on the right. In that way it looks very similar to the first problem on this page, but we're given some very different information. Here we're given that measure of angle 1 equals the measure of angle 2. Okay, so we could denote it in that way. Each of these two angles are congruent. And we're also given that BD is perpendicular. Remember, this is the perpendicular sign. BD is perpendicular to AC. So we've got this is a right angle and this is a right angle because, well, we're jumping ahead of things a little bit, but we're going to have to write that into the proof. Okay, so now let's go ahead and see. We're given that measure of angle 1 equals measure of angle 2 and that BD is perpendicular to AC. And now we're going to have to come up with a reason why these two triangles are congruent. So we have two angles congruent, 1 and 2, and that's all we're given. But we kind of hinted at one of the next things that we were going to do here. We know that angle 3 and angle 4 both have to be right angles. Okay, angle 3 and angle 4 are right angles. And that's because of the definition of perpendicular lines. Because the definition of perpendicular lines are lines that intersect in right angles, so that every angle created by perpendicular lines is a right angle. But what does that exactly get us? We have to prove congruence here. But you may remember that there is a theorem that all right angles are congruent. Okay, so that's what we would use next. We would say that the measure of angle 3 equals the measure of angle 4 because all right angles are congruent. So we've got now two congruent angles. We've got angle 1 congruent to angle 2 and angle 3 congruent to angle 4, or as we've expressed it here, they have equal measure. That is more or less the same thing. Okay, but we need something. We're going to need a side. Either a side down here, here, or here would work well because we could do either angle, side, angle, or angle, angle, side. But we need to find a corresponding side. Well, I hope, again, you realize that BD is congruent to itself. Line segment BD is a shared line segment between both triangles, and we've got BD equaling BD because of reflexivity. Okay, and therefore, we have what is the congruence proof here? What is the congruence criteria? What is our reason for saying that triangle ABD and CBD are congruent? Angle, side, angle, and angle, side, angle. Okay, so B and D have corresponding positions in each triangle. As you can see, B and D are the second and the third position in both of the congruent statements. So we have angle, side, angle. And that is the reason that we can conclude that the two triangles are congruent.